Imagine a grand symphony conducted by an endless number of planets, stars, and moons, each of which contributes to the performance. However, in perfect harmony, there is a specific section of this cosmic orchestra that has ensnared the astronomer's attention for a considerable period. These are exoplanets, planets that exist hidden outside of our solar system, somewhere in or near the vastness of the Milky Way. It might surprise you to learn that there are so many celestial bodies, strikingly similar exoplanets, so remarkably similar to Earth that they could be the cosmic counterpart of our planet. Allow us to enter Proxima B, an intriguing realm located just 4.2 light-years away. The James Webb Space Telescope plays a crucial role in our endeavor to decipher these cosmic mysteries. Imagine the mysteries now in your mind, traversing the enormous Milky Way galaxy, home to more than 4 billion exoplanets. To put that in perspective, suppose that each of the exoplanets was comparable in size. They wouldn't just fill with sand grain, they would go far beyond the Grand Canyon, beyond the fact that it made a second monumental geological feature, the Grand Canyon 2.0. It is an enormous expanse. Surprisingly, approximately 20% of these massive items have been referred to as Earth-like in terms of their geography and climate conditions, which indicates that 1 in 5 opportunities exists to locate a twin of our planet. And that's just the outside. These planets might also be accompanied by quadrillion moons and mountainous satellites, stuck in a dance of gravitation with their parent planets, taking into account the possibility of locating a different celestial body that could, or might, in the future, host life. The universe is full of possibilities. Now that we've laid this out, let's introduce the ultimate instrument for locating its complexities, the James Webb Space Telescope. This cosmic detective is equipped with a larger primary mirror made of flexible sections, which exceeds even the most cutting-edge optical instruments. This is not your typical lens. It's 6.5 meters in diameter, nearly 2.7% larger than the Hubble Space Telescopes. Imagine the tiniest of details captured, even from the tiniest hint of movement billions of light-years away from a distant star, and then examining the planets around it. The James Webb Space Telescope is truly revolutionary. It is not only powerful but also has advanced technology, including sophisticated sensors and spectrographs that do far more than just observe. They can examine and process the incident light reflected by these massive constellations, allowing researchers to decipher their composition, atmosphere, chemical balance, density, and even mass. Working together with astronomers based in space, the telescope can check to see if a planet contains organic compounds, water, or even oxygen. The James Webb Space Telescope has the extraordinary capacity to answer these inquiries, elevating it from a simple observer to a genius in science. It is more than just an improvement over Hubble, it represents a leap forward in our comprehension of the universe. You were amazed by Hubble's discoveries, but now prepare for a truly remarkable period of revelations as our scope of comprehension grows. Let's concentrate on a single star in this narrative of the heavens, Proxima B. Since it was first discovered in 2016, this mysterious planet has enthralled astronomers and biologists alike. Comparisons to a play by Shakespeare, filled with intrigue and complexity, come to mind. So, what makes Proxima B so appealing? It is extremely near our own galaxy, located within 4.2 light-years of Earth. To put this into perspective, if we could travel at the speed of light, it would take just over 4 years to reach. This is approximately the same amount of time it takes for a TV show to become a cultural phenomenon. Now consider the importance of this closeness in the vastness of the universe, which spans more than 93 billion light-years. The discovery of a planet so close and ripe for scientific investigation is like finding a diamond in a mountain pile of rocks, containing a valuable gem that could keep important secrets about life. Proxima B itself has the potential to modify everything that we know about existence and habitability beyond Earth. Not only is it close to Earth, but it also hints at something even more intriguing. It might be more than just similar, it could be Proxima B, Earth 2.0. Proxima B resides in harmony with its parent star in what scientists call the habitable zone, where the circumstances are neither excessively warm nor cold, but just right for there to be liquid water. Picture winding streams, cascading waterfalls, vast lakes, and possibly even oceans as mysterious and deep as the Mariana Trench. But before we allow ourselves to dream about traveling to Proxima B, we must take into account a few characteristics that set this faraway world apart. Each day on Proxima B is only 11 Earth days long. Imagine dawn, which not only marks the beginning of a brand new day, but gradually progresses into more leisurely afternoons and sunsets that linger, generating golden opportunities for photographers. Even though this may sound idyllic, it has significant repercussions for climate and its potential for habitability. How would humans support life on Proxima B? We would require both light and dark cycles of the day. To account for how long its days are, we might need to consume multiple meals daily. Our sleeping habits would also have to adjust. Proxima B's life could be remarkably similar to Earth's, yet strikingly different in ways we can't yet predict. It's a cosmic puzzle to solve, despite the mystery nature has presented to us, hidden behind a mystery that challenges our comprehension of what constitutes a planet suitable for life. How can we then assemble reliable and accurate information about a planet that we have not yet visited? This is where the James Webb Space Telescope comes into action like a massive Swiss Army knife, a sharper instrument for scientific investigation. It does more than just function as a telescope. It is a powerful laboratory in the vast emptiness of space. With its cutting-edge instruments, astronomers can look further afield than just planets and examine them using a range of scientific tools that are so advanced, they make even the most sophisticated earthly laboratories look straightforward. The Webb telescope can use spectrographs to examine the reflected or emitted light from these far-off planets. Every element or molecule in a planet's atmosphere interacts with light in various ways and wavelengths. By concentrating on these patterns, researchers can study celestial bodies' remote biopsies, revealing vital information regarding the composition of their atmospheric pressure and the possibility of life-sustaining substances like water molecules, carbon, and even oxygen. Space science is more than just studying distant stars. It is the exploration of possibilities, the unraveling of cosmic mysteries, and the search for life beyond our world. As we continue to explore these possibilities, the James Webb Space Telescope is paving the way for groundbreaking discoveries. Its ability to observe distant planets with such precision will allow astronomers to identify even the most subtle signs of life. This opens up a realm of possibilities for humanity, offering a chance to understand the conditions that could support life elsewhere in the universe, whether it be on exoplanets like Proxima B or others that may exist in the far reaches of space. The real excitement lies in the future. With every new discovery, we take another step toward unlocking the secrets of our cosmos. Proxima B, with its Earth-like conditions and proximity to our solar system, offers a tantalizing glimpse of what could be possible. Imagine a world where we can one day travel to another planet, perhaps even colonize one, where the conditions are just right for life to thrive. The concept of a second Earth is no longer just science fiction. It is becoming a tangible goal thanks to the advancement of space exploration technologies, particularly the Webb telescope. Moreover, the discoveries made by the Webb telescope will not just be confined to exoplanets. Its instruments will help us learn more about the formation of stars and galaxies, the nature of dark matter and dark energy, and the very origins of the universe itself. This telescope is, in many ways, our window to the past, present, and future of the universe, allowing us to peer into the distant reaches of space and time. But while the Webb telescope will certainly reveal much, it also raises new questions. As we find more Earth-like planets, we must ask, are they truly capable of supporting life as we know it? Could they harbor life forms that are entirely different from anything we have encountered on Earth? And how might our discovery of these new worlds affect our understanding of life itself? This search for answers is not just a scientific endeavor, it is a deeply philosophical one. It challenges us to reconsider our place in the universe and our relationship with the cosmos. Are we truly unique in the vast expanse of space, or are we just one of many forms of life scattered across the stars? The discovery of life on another planet, or even just the discovery of an Earth-like planet with the potential for life, could profoundly alter the course of human history. As we look ahead, the James Webb Space Telescope will continue to be at the forefront of our exploration of the universe. It will help us answer some of the biggest questions humanity has ever asked and raise new ones that will keep us searching for generations to come. The journey into the cosmos is just beginning, and with each discovery, we come closer to understanding our place in this vast, mysterious universe. Space forensics researchers should not wait idly, looking for clues. They should actively search for them, examining the molecules and atoms that make up these faraway worlds. The Internet Telescope is more than just an indifferent observer. It is an outstanding research facility, a specialist, and an extensive analyst, all playing roles into one. This allows us to evaluate our hypotheses regarding the offerings of distant worlds with specific data that can either support or test our hypotheses. Just when we believed we had discovered all the mysteries surrounding this cosmic investigation, something unanticipated occurred. Researchers who make use of the James Webb Space Telescope picked up an amazing signal from Proxima B, a signal that is so complex and unusual that it brought about excitement and debate among scientists worldwide. This signal was dubbed, on social media, a possible technology signature, a so-called electromagnetic radiation, strange and intricate, raising the possibility of cutting-edge technology civilizations. For a brief time, it appeared as though humanity's collective pulse had stopped, marveling. Could this be the breakthrough discovery that demonstrates we are not yet the only ones in the universe? As soon as the signal was received, it disappeared, leaving a profound silence and numerous unanswered questions. There were concerns about whether this was merely a cosmic fluke, a natural anomaly, or something more thoughtful, perhaps an encrypted message or signal from an intelligent civilization on other planets. This single signal has produced a cloud of mystery surrounding the explosion of interest in Proxima B, with spirited arguments and theories about its origin. Was it a brief blip, or could it be part of a bigger story, one that is more complicated than we can even imagine? But the narrative doesn't end here. The search for answers continues, and it is no longer ordinary. Researchers from Harvard and other institutions are testing the limits of our knowledge, changing the James Webb Space Telescope into a kind of cosmic night vision instrument, looking for artificial sources of light in both dark and lit areas of the distant universe. The possibilities in these worlds are staggering. Imagine spotting city lights on planets far away, their lights out like beacons of light in the gloom of advanced civilizations, not only in the search for meaning in life, but in locating evidence of intelligent beings influencing their surroundings in ways that we might not have taken into account. As we dig deeper into space's vast expanses, the search for alien life on other planets takes on new dimensions, fueled by the rapid development of technology and a keen interest in our connection to the universe. This drives us to look into the world beyond Proxima B and the universe's farthest reaches. Tools like the James Webb Space Telescope, in addition to ground-based observations, provide unparalleled understanding of exoplanets, which opens up new ways to learn about life and comprehend the possibility of habitability of these faraway worlds. One of the most intriguing areas of investigation is the search for chemical biosignatures, markers in the atmosphere of a planet that could indicate biological activity. These could consist of gases such as methane or carbon monoxide, which, under the right circumstances, may point to the presence of life. With James Webb's capabilities, scientists can now study these chemical signatures with amazing precision. By studying the illumination that passes through an exoplanet's atmosphere, astronomers can identify important molecules like water vapor, ozone, and oxygen that may indicate conditions suitable for life. In addition, the study of the environmental conditions of these planets is essential. Models based on Webb's data aid in determining whether the temperature of a planet may permit liquid water, which is necessary for life to exist. A planet located in the habitable zone of its star is especially promising, as it's possible that the right conditions for water to remain stable and liquid may exist there. Moons circling some of these exoplanets may contain oceans beneath their icy crusts, similar to Europa and Enceladus in our solar system. The concept of technosignatures is growing in popularity. Possible evidence of extraterrestrial technology, whether it's big energy technologies utilizing structures such as Dyson spheres or strange radio transmissions. As we refine our methods of observation and construction, greater international cooperation in the search for technosignatures may provide long-awaited proof of advanced alien civilizations. Collaboration is essential. Cooperation among space agencies, private research organizations, and businesses is improving our collective ability to look into space. As we embark on missions to other celestial bodies like Mars, nations are pooling resources and know how to scale new heights in space exploration. Public engagement is essential for keeping excitement alive and motivating the next generation of engineers and scientists to carry on the search for life in the universe. The investigation of exoplanets and the search for life on other planets is a rapidly changing and dynamic field. With each step forward, we get closer to answering some of the most fundamental human questions regarding our role in the universe. As we continue to investigate the stars, the potential for the discovery of novel forms of life and a deeper understanding of the vast universe is exhilarating. There is still much to learn, and this search for knowledge encompasses more than merely an intellectual endeavor. It's a testimony to our curiosity and our need to communicate with the universe in a significant manner. With each new discovery, we question the very concepts of life, intelligence, and existence in a universe so vast. Whether through the finding of chemical traces from faraway atmospheres or the possibility of observing technologies that are alien to us, the search for extraterrestrial life goes on. The consequences of discovering life beyond Earth would not only redefine our understanding of biology, but would also change our perspective on our place in the grand tapestry of existence.